So looking at the first one, it says you receive a pay raise of 5%, and then after the 2 changes in pay, your salary is, or then you receive a pay cut of 5%. And after those 2 changes in pay, your salary is unchanged. Is that true or false? And if it's false, how does your new pay compare to your original salary? So let's see. First, you get a pay raise of 5%. A raise indicates positive. So it's an increase. And the increase, if you change it to a decimal, is 0.05. So that means that you start out with 100% of your salary. And then, since it's an increase, you multiply that times positive 0.05. But then you get a pay cut of 5%. Which is 0.05 again. And it looks like if you don't think it through and you just think percents, well, these two cancel each other out. Like when you solve an equation, 0.05, negative 0.05, they cancel out. But let's see if that's actually what happens. So we're going to then multiply our 100% salary times 0.05. And let's see what happens. And this, remember, is negative 0.05. Now, what do we do with that negative 0.05? Well, since it's a cut, what we're doing here is we're actually taking 100% and adding 0.05. But here, what we're doing is whatever you're making at that point, since it's negative, you're actually going to subtract to 0.05. So you're going to actually lose that the 5% here, but you're going to gain it here. So rather than do the multiplication that I set out to do, remember plus means add, that's going to be 1.05. which gives you 105% of your salary. And then since this is being subtracted, sorry, I wrote that in the wrong place, then this is actually 1 minus 0.05, which is actually only 0.95. So instead of putting negative 0.05, I'm going to put positive 0.5. Because if you're getting a raise, that means you're adding that percent to your 100%. And if you're subtracting, you're getting a pay cut, then you're going to subtract that from your 100%. So let's see what happens as the final result of all of that. You take your 100%, which is percentage points, that's 100 percentage points of your original salary, times 1.05. Times 95.95. And it says, well, actually, when you're done, you're only going to make 99.75% of your original salary. So actually, that's false. You do not have your same original salary. You didn't lose much, but you did lose 1/4 percentage point of your salary. And going to the idea, like we did last time, of, okay, what if my original salary is $100? If I get a 5% raise, how much is my raise? $5. And it's a raise, so I'm going to add $5, right? So my new salary is $105. And this is the first time period. Remember, this is what happens first. And it doesn't say how long that is, but it really doesn't make any difference how long it is, if it's 6 weeks, 6 months, a year. After that first time period, however long it is, I'm making $105 that whole entire time period. Then what happens is that I get a 5% pay cut. So that means they're going to take 5% away of my $105. So my pay cut looks like this. So at that point, I'm going to make $105 times 0.95. Which means I'm going to make $99.75. So that's the rest of the time, or the second time period, for however long that lasts, and then they might make another change. Okay, now if you're wondering, why did it look like I did that differently? I really didn't. Because my salary at this point was 100 times 1.05, which is my $105. It was just easier to talk about. This is how much the raise is. Your actual cut of that $105, oh, thank you. Is $5.25. And since that's actually a negative, this makes this a negative $5.25, which when you add that to your $105, which is your pay raise, with your pay raise, then that means you actually lost $0.25. Okay? So if you're not sure if you did the arithmetic of the problem in the correct order, what you need to think about is, okay, what if I get a raise? How much is it? How much do I have when I get my raise? That becomes your new 100%. And then, okay, now I'm going to get a pay cut based on my little bit higher salary. So if I take away that pay cut, what happens? Am I back to where I started? The answer is no. Okay? So you can always reason through these. Next problem says 30% of the class, that means all of the class, 30% of the class has blonde hair. So what my picture looks like for that is my whole class Looks like this. And it says 30% of them have blonde hair. So 30% is 0.30. Remember, you move your decimal backwards. If you've got percent to decimal, you go backwards. And 30% of the class then, which is a smaller amount, has blonde hair. And then it goes on to say, and 20% of the class, the whole class, 20% of the class, not of the blondes, but of the whole entire class, wears glasses. Now this is a new group. But the question is, are there any blondes that wear glasses? Well, if 20% of the whole class wears glasses, then 20% of the blondes wear glasses. That makes sense? 20% of my whole class wears glasses, so 20% of my blondes should wear glasses. So that means the blondes with glasses should be that 0.30 times that 0.20, which is 0.2 times 0.2, 0.3 is 6, and it's 0.06. You can always check that on your calculator. So 6% of the blondes wears glasses. And it says, does it follow that 6 of them wear glasses? And the answer to that should be yes. Now let's, once again, because I've told you to kind of use your little example. If this is 100%, this is all my class. Let's just assume that my class, since it's 100%, let's assume that's 100 students. Right? Now, if my class is 100 students, how many of those students are blonde? Well, this says 30 out of 100. Or 0.30 times 100 would give us 30 blonde students. And it also means that we have 20%, or 20 out of 100, 20 of the whole class wears glasses. But that also means, since this 20% applies to the blondes as well, 20% of the blondes then also wear glasses. So 20% of those 30 and the question is, does that come out to be 6 students? And it does. So 6 out of 100 are blonde students with glasses. Okay? Read your problem and decide, is it talking about a percentage of the whole class or a percentage of just those that have blonde hair? So then our last problem says, half the town's population agree with the mayor's revitalization plan. Okay, here's the whole population. That's your 100%. And of that 100%, we keep reading the problem, says half of the population agree. Well, half is 50%. So if I take 50% of that population, I get a smaller population that agree. With the mayor's revitalization plan. And then it goes on to say 20% of those that agree. 20% only of the ones that agree volunteered. And then the question they ask us then is, does it follow that 10% of the town's entire population agree with the mayor's plan and have volunteered to help with the revitalization? Well, the straight out answer is, how many is 20% of this 50%? So 20% times 50% is 10%. So yeah, it does seem to be that 10% of the entire population agrees with and will volunteer. Now here's how we decide if that's entirely true or not. Let's suppose the whole population, again, is, since it's 100%, we'll say that there's 100 people in the population. How many people agree? Half of them, so that's 50 of them. Now, 20% of that 50 would be how much? 10 people? So 10 people volunteer. Now let's check and see if that jives with this last statement. It says, does it follow that 10% of the population? So that's 0.10 times 100. What's 0.10 times 100? That's 10. So yes. So it matches what we came up with. So then we're sure that we're correct. Now the easiest way, really and truly, the easiest way to do these kind of problems when they ask you is to draw pictures so that you realize what the whole group is, and then the little group comes off that group, Does the other littler group come off of the whole group, or does it come off the part of the group? Okay? Any other questions about anything? Okay, several of you had questions about problem number 10. That seems to be the main bone of contention on the quiz, and since I know you will see problems like those quiz problems, I'm going to do I already had it set up to do problem number 10, but if I have time, I'm going to do the actual entire whole quiz and record it with explain everything, and then I'll post a link to it on the quiz page, so that if you missed one, you'll be able to understand why you missed it. Okay? Because we don't want anybody still not understanding come Monday. Everybody does remember we got an exam Monday, right? No?
I keep remembering.
Okay, well, will you remember now?
I will now.
Okay, let's get started talking about our last topic, which is the Consumer Price Index and other price indexes. And then I had a question too about one of the portfolios, so I'm going to try to look at that too. If I don't get that one looked at, I'll make a recording for that too. And if anybody doesn't have any kind of storage in the cloud, any online storage, and you don't like carrying around a flash drive with you, if you'll send me a message and remind, I will send you, you'll need to send me your email address that you normally check. But if you'll send me a message and remind, I will send you an invitation to Dropbox. It's free. It gives you, it's not a huge amount of space, but you get quite a bit of space for free. And basically all you do is you install Dropbox on your computer. You can also install it on your iPad. You can install it on your iPhone or your Android phone. It is just simply like a virtual flash drive. And the good thing about it is, unlike your flash drive, once you make changes like maybe from your laptop, it saves back to the Dropbox. And when you go to your iPad and you open your Dropbox, then the changes you made on your laptop are saved still into the Dropbox. So you can make changes on one machine, it'll automatically carry every place that you got your Dropbox installed. It's a lot easier than having to carry things around and keep up with flash drives. And I want to have this particular thing up because I'm going to need to pull up some of these indices when we need to use them. So I'm going to have it sitting over here to the side for a second. So the primary purpose of index numbers is to facilitate comparisons. Basically to make it easier to compare one thing to another thing. Okay? An index number, this is the definition of an index number. An index number provides a simple way to compare measurements made at different times or in different places. Different times being, y'all have grandparents, you have parents, and, how many times do they talk to you about, how different it was when they were your age, okay? How they paid a lot less for gas. Of course, there was always, that they had to walk a mile uphill in the snow to go to school and all that stuff too. But we're basically going to talk about prices right now. Do you suppose your grandparents paid the same thing for a loaf of bread that you pay? No. No way. I mean, I know for a fact my grandmother didn't, because my grandmother raised me, and I remember when she went to the grocery store, it seemed outrageous to me when I was buying my own groceries for the first time that my granny could go and buy a week's worth of groceries for $3. And by the time I got to be an adult, that had gone up to, and y'all don't laugh now, that had gone up to a whole, this is for 2 people, a week's worth of groceries was $10. And she spent $3 on a family of 4. But now, $10, I go to the grocery store, I can't buy dinner for me for $10. So things have changed, and that's what we're talking about, prices at different times. How do you compare? Because obviously, I did not make the same amount of money that my grandfather made. I can remember my grandfather telling me stories before I was born that he worked for 50 cents a week at the creamery in Rogersville. 50 cents a week. We can't imagine that now. When I went to work at my first job, when I was an adult, my first job, I made a whole big $2 an hour. Man, that was like a fortune because I had a good job at that point. I could buy lots of stuff on $2 an hour. Now, and what's really sad now is now a waitress, which was not what I was then, but a waitress now makes like, what, $2.25 an hour? Plus tips?
It's like $2.15 right now.
Excuse me?
It's like $2.15.
$2.15, oh wow. Like you could actually even afford to drive to work on that. When you go into a restaurant, please tip generously if you weren't aware of that. Because those people are depending on you to help them get there. You're paying for their service, bringing you a meal. The check is only for the meal. But then, I think $2 an hour, that's nothing now, if that's all the money I have coming in. So things have changed a lot. As we move through time, prices change, wages change. It's also true that in different places, things have different values, different costs. The price of a gallon of gasoline in the United States is far less than what it is in Canada. But it's also, even Canada and us both, we're both far less than what it costs in Europe. In Europe, it's outrageous. And then if you compare it to what it costs in the Arabic countries, like we're paying a huge amount and they're paying much less than that. So an index would let us compare gas prices from one place to the next too. So a value at one particular time or place has to be chosen as the reference value. So you need to be thinking about a reference value. Who's going to be the reference value? You're going to be the one that everybody else is measured against. So if we were to be the United States as the reference value, then Canada would be compared to us. We would be the reference value. France would be compared to us. We would be the reference value. And the way that works with indices is the reference value has a number of 100.0, which means it's the base value of 100%. Okay? Once a reference value is chosen, the index number for any other time or place is actually calculated by being the amount for the time or place in question, like the cost of gas in Canada, or the cost of a loaf of bread in 1960. And it's going to be divided by the reference value. And it's then going to be multiplied times 100 because the money over money is going to give us a ratio, a fraction, and we want to make it into a percentage, so we want to change it back. So we're going to multiply it by 100. We're actually multiplying by 100 because the reference value's index is 100. So here we've got some index numbers. And remember that an index number is the money for the time or place in question divided by the reference value times 100. Well, since we're the United States, you know, and we want to compare everybody else to us, we're going to choose us to be the reference value. So if we are the reference value, the United States is $2.12, and we are going to figure out some price indices. Now I'm going to come back to this, and we're going to move over to my notes so that I can work these with you. So first thing we're going to do is we're going to choose the United States to be the reference value. Because we're just like that. We like to compare everybody else to us. So what does that mean? Well, that means by definition then, because we're comparing everybody else to us, our price index is 100.0. And even though you normally don't see it, that just means we're the 100% mark. Most index tables don't have the percentages on them. But we're the 100% mark. The people that charge more than we do are going to be higher than 100%, and the people that charge less than we do are going to be lower than 100%. Going to be less than 100%. So the first country I want to look at is Hong Kong. So let's look at Hong Kong. If I want to find the price index for Hong Kong, what I do to find that index, I'm going to slide this down a little bit. Hong Kong's index, remember, we're the reference value. So it's always the other place divided by the reference times 100. So if we're talking about Hong Kong, we're still going to have the 100 because we're the 100% mark. But that 100 is actually tied to the bottom number because we're the reference point. So what is the actual price, the money, the price in dollars, what is the actual price of gas in the U.S.? $2.12. Okay, now the other number is the price of gas that we're comparing in Hong Kong. And that's $7.12. So it's the other place's money over our money times 100 because that's our index value. We just don't normally always put that 0.0 after it. Okay? So let's see how much that is. Hong Kong's money is $7.12. Same thing in our country, gallon of gas costs $2.12. So their price index is 335 point, and we're gonna round the index to 1 decimal place, so it's 335.8. Actually, since it's money, you can round it to 2, and that would be 335.85. So there's your price index. And what that means in the long run, and that's not dollars. That's just a price index. So don't put dollars in this column. I messed up. If you change that to a percentage, then that means that this is 335.85%.
So it doesn't go in the end?
No. Because the index actually is kind of as a percentage. It's not usually shown as a percent, but it really is a percentage. And the reason it's a percentage is because it's a fraction times 100, and that makes it, you know, the ratio per cent. Okay? That keeps us in with relative comparisons because that's what we've been doing this whole time. So does anybody have any questions about why Hong Kong's index is 335.8 or 335.85? Okay, let's talk about another one just to make sure we've got this. What if we're talking about Bermuda? We would like to find the consumer price index, or I'm sorry, the gasoline price index for Bermuda. Same process. The only difference is that instead of using Hong Kong's money, we're going to use Bermuda's money, which is $6.85. So if we take $6.85 and again divide it by the reference value, which is $2.12, and then multiply that times 100, our index is 323.1. Okay? And as a percentage, that will be 323.1%. So what that means then, gasoline in Hong Kong is 335.8% of what it is in the United States. Over 3 times as much. Gas in Bermuda is 323.1 times what it is in the United States. So it's, again, over 3 times as much. Well, let's do one more just so that you understand.
Is there a reason why you only rounded one place that time?
I kind of misspoke when I did this one here when I left that dollar sign, because what actually happens is since both of these are dollars, then the dollars cancel the dollars and you actually are left with just a number. And since our index is 100.0, we should actually round all of them to 100.0 or to 1 decimal place, same number of decimal places. So if you want to scratch out that 5, that's fine.
Should it be rounded, the 5 down to?
Well, remember in the original it was 0.84, so it would have rounded to 0.8. Okay? So So for one more, let's look at just out of curiosity, let's look at Saudi Arabia. And let's calculate the index for Saudi Arabia. So for Saudi Arabia, I'm going to move this up here temporarily so I can give you some notes. For Saudi Arabia, remember that it's the other number, which is Saudi Arabia's number, which is 0.95. Move it up so we can see the United States. And it's going to be times 100, because the index is always times 100, and our price is 212. And our price is tied to our index, and that's our index. Okay? So that means then that for Saudi Arabia, it's 0.95 divided by our money amount, $2.12, and then times 100. So Saudi Arabia's index is 44.8. Okay? That means that Saudi Arabia's gas prices are less than half what ours are. This last column is actually just so that you interpret what the index is telling you. Okay? So Saudi Arabia's gas prices are 44.8% what ours are. Now what I'm going to do here is I'm going to stop for a minute, and I'm going to let you all fill in the rest of that table. And then I'll show you what the actual numbers are. So work with the people around you. Take a few minutes. I'll walk around and let you ask me questions. Take a few minutes and finish that table. Okay, if you want to check your answers, you've got the PowerPoint slide, and it does have all those figured in, all those filled in for you. But to make it bigger so you can see if you're looking up here, Greece is 289.2, France is 262.3, Belize is 217.9, Zambia is 169.8, and Iraq is 117.9. The United Arab Emirates is 80.2, and Libya is 19.8. Okay? So for an example, I'm planning a trip to Panama. The gas prices listed there is $2.31. What is the gas price index, or the index price for gas in Panama? What is their CPI? Now notice that Panama is not in the table, but they've given me the information that would work for Panama. So I could actually add Panama to the table if I wanted to, simply by using the formula. So it says their price listed for Panama is $2.31. Okay. We're still comparing them to us. We're still the reference value. So the reference value is the 100, and it's tied to the denominator, which is 212. But Panama, price of gas is $2.31. Now, are they pretty close to us? Yeah, they're pretty close to us. They don't charge that much more for gas than we do. So we're expecting the amount or the index to be a little more than ours because their price is a little higher than ours. But not a whole lot higher than ours. So a little bit more than 100. So let's actually calculate their index. And their gas price index is 108.96. And since that's 108.96, 6 says that the 9 would round up to 10, and if the 9 rounds up to 10, then the actual index is going to be 109.0. Be careful with your rounding there. Okay? Okay, let's work some index numbers practice here, and let's work through these kind of as a group. I'm not going to answer all of these. I'm going to let you do some of them, but let's see if we can answer some of these questions before we do that. Use this table to answer the following questions, and it's the 1998-99 median income index. And it's listed by state and income, and then they give us the index value. So based on that table, which state is being used as the reference? How do you know? That's right. Since this is 100, that means Arizona is the reference. So in the second spot, given that the 1998-99 median income for California, is California a table? No. So for California was $42,791. Find the median income index for California. Okay, for California, we use their money amount, which is $42,791. And then we divide by the index value for the reference, their money amount, to get the index for California. And then remember, the index is tied to that bottom amount, and the index is always 100. Now, California is higher than Arizona, so what does that tell you about the index? It should be greater than 100. So let's do 42,791 and divide it by 37,514, and then multiply by 100 to change it into an index value. And it is 114.06. Which tells me that rounded to one decimal place is going to be 114.1. So the income index for California would be 114.1. Okay? Now here's a slightly different question. It says if you live in Arizona and you make $45,000, but you're considering a job offer in Alabama, how much would your salary have to be in Alabama to keep the same standard of living? That's a very different question from what we've considered up to this point, which is why I wanted to work through this one with you. Let's talk about this. In this problem, and remember, we've got both Arizona and Alabama in the table. Right now you live in Arizona and you make $45,000. If you move to Alabama, how much would your salary have to be just to stay the same? Does it have to be what you're making right now in Arizona, or can it be less? It could be less because Arizona's index is 97.7, which means that your salary, if you move to Alabama, would only need to be 97.7% of what you make right now. And what you make right now is $45,000. So if you take your percentage, your index, and convert it from a percent into a decimal so you can multiply by it. And if you convert your 97.7% to a decimal, that's 0.977. And this follows the same pattern that we've used before. Then you would only have to make $43,965. If you move to Alabama. Okay? So you could afford to take a little bit of a pay cut. Now, I want y'all to work together and see if you can do problem 4. If you live in Arkansas and make $45,000, and you're considering a job offer in Alabama, how much would your salary have to be in Alabama to keep the same standard of living? Now remember, we're not talking about Arizona at all this time. You're starting out in Arkansas. That changes some things. Who's going to be your reference here? Arkansas.
Versus that state's median income, if I can work it out.
So you're going to compare Arkansas to Alabama. So where does Arkansas go in the ratio?
Yeah.
It goes to the bottom. Okay? Goes to the bottom. So you're not, it gets back to what you asked me earlier. Now, we're comparing ourselves not
That's the
to
median state.
Alabama, where we started out with. We're starting out in Arkansas and comparing Arkansas to,
So we have to figure out what's the median. That changes the index.
we're comparing Arkansas to Alabama. Arizona has nothing to do with it. Okay. So for this problem, you go back here and you use this value,
Whether you still use an hour.
this value, and this is where you start, so that ain't change value.
Yeah, we're moving from
Okay.
Arkansas to Alabama, not Arizona to Alabama. So our reference point changes.
Because that's where you start, on the top. So you got what you need in the table, but you can't use those indexes. You have to make it, you have to use income, that's right, you're using the income. What you actually do is you're gonna come up with the index using Arkansas as a reference table. It's like you created a new table. Except you only have to do it for one entry. Just Arkansas, Alabama. Okay, where do you live? Okay. But here, you live in Arizona. Right. Now, if you move to where you live in Tennessee,
I get that it's a different place.
Yeah, the sentence basically says that,
then this is your ratio times 100. This is your index.
like, this table up here makes it, implies that we live in Alabama or Arizona, so that's our point of reference. So wherever you're standing is your point of reference. So it's saying that we're in Arkansas, so if we figure, we get a new index number based on how we live in Arkansas. So we can get Arkansas.
And then we'll follow 100.
Yeah, they're very cut and dry, just fine.
So their index is 81.4. So if you take that, 81.4 and convert it back to a decimal, 0.814 times this, which is what we did here, then you'll come up with the salary that you need to have in that. Just like you did the problem before. No, you won't put your decimal in front of that, because you, that's a percent, you need to make it into a, back into a decimal to use it. So you only need to make that much money.
that's because the median income
The index
in
number, that's-
Alabama is less than the
Money
median
value
income
tax.
in
So I just took
Arkansas.
these.
So you're moving so
And
much
changed
cheaper.
I changed the reference value, right, so, this doesn't make any mention of the reference value, right, so.
So how much do you need to make if you move from Arkansas to Alabama?
56,872.
Okay. Let's go back and look at the table. You live here. You make this much money.
I thought it said you made a different amount in the problem.
Okay, but we're treating, you live here, we're treating this as one. Okay, there's your 100%. Okay? So we're gonna use them as the reference value. In other words, we have to make them the 100. Okay? And then you're going to Alabama. Is Alabama's income higher or lower? Okay, it's higher. So is the index going to be more than 1 or less than 1? More than 1. So the first thing we need to do, remember, if you live in Arkansas, then Arkansas is going to be the 100. And Arkansas's money value is how much? Okay? You need to connect those two. Arkansas's money is your reference value. Now what's the reference value for Alabama? You're moving to Alabama. Okay, Alabama's reference, 36,640. Their money. So then when we do the math, now are you expecting an index number higher or lower?
Higher.
Higher because you're moving to a state that has a higher median income. So you should get something more than 100%. So that's 1.2626 times 100. One 126.26. Since the 6 is more than 5, your index is 126.3. So you need to make 126.3% of your Arkansas salary. And the way that you do that is you take your Arkansas salary, which is $45,000. You go back and you actually don't use the index number because that's a percentage. You actually go back to before it was a percentage. change it back to a decimal.
I thought the Arkansas salary was 45,000.
Your actual is, but the median in Arkansas is $29,019. $29,019. Be careful that you're using your actual median income. This is what you're gonna make. This is the median income in all these states. So you always go back to the money that's the normal for the state that you're going to, regardless of what you're making. You may be making more or less than that normal. Okay? So that's why you use the 2901, because that's making Arkansas under the reference value. And that means that we would have to come up with a new index, which we did for Alabama. So then when I multiply, I need to move this back to 1.263, and I'm going to multiply 45,000 by 1.263. Times my 45,000 that I personally make. So if I move from Arkansas, where the median income is only $29,019, to a state like Alabama, where the median income is quite a bit more than that, $36,640, that means their index value compared to me in Arkansas is 126.3, so I'm going to have to make 126.3% of my current salary, more than my current salary. So when I do that, I multiply 1.263, my new salary would have to be $56,835. And that's if I want to live in Alabama. Remember, your reference number and your reference money goes on the bottom. The place that you're going to, their money goes on the top. When you get that ratio and you multiply it by the 100 for the index, that gives you what percentage your new would have to be from where you started, which is your reference. And in order to use that percentage, you actually have to convert it back to the decimal to be able to multiply by it. Okay? Let's look at number 5. Now, I'm going to have you do the computing. But I'm going to ask you a question first. Compute the index numbers using Alabama as the reference. What does that mean about their index? What does that mean about Alabama's index? What's their index? Okay, it's going to be the 100.0. So compute the index for Alaska. Is it going to be more or less than 100? More. Because Alaska's higher. Compute the index for Arizona. Is it going to be more or less than 100? 37.5 compared to 36.6. It's going to be more. Is it going to be a lot more? No, only a little more. This is going to be a lot more. What about $29,019? Okay, they're less, so your index is going to be less than 100. Now, y'all finish in the table. I'll give you a minute to do that. And we'll check answers.